So today we're starting our systems of equations unit, and today we're going to learn how to solve them by graphing. So first we're going to be able to determine if an ordered pair is a solution, and then we're going to be able to solve by graphing. So let's start with the first. How to tell if an ordered pair is a solution. Here's my first question. Is the point -2, 4 a solution to the equation 2x minus 2y equals 8? Why or why not? So, think about it like this. -2, 4 is an x value and a y value. And in my equation, I have an x value and a y value. So I can plug in my x and y into my equation and solve. So I'm going to start here. There's that 2. When there's nothing in between the 2 and the x, that is multiplying. So I'm multiplying 2 times the x value, and my x value is -2. Minus 2, and my y value is 4, so 2 times 4. And I'm saying that equals 8. When I simplify, I get -12 equals 8. -12 does not equal 8. Because of that, this is not a solution. So to answer why or why not, the answer is no, because -12 does not equal 8, meaning it is a false statement. When we have a false statement, we do not have a solution. So that's one and done. We're going to do it a couple more times down here. But let's talk about what a system of equations is. So think about what a group of sheep is called. A group of sheep would be a flock. Okay? A group of cows is a herd. When we have a group of equations, it's called a system. And because it's a group, we have more than one equation that must be true at the same time. In other words, more than one equation with the same solutions. In our case, most of the time, it's going to be x and y. Okay? So, to continue with determining if an ordered pair is a solution, you will be given a system. So that's more than one equation. You'll only ever be dealing with 2 at once. So 1, 2. And here's your ordered pair. So we're going to start with step 1. We're going to substitute the x and y values into each equation and determine if the equation is true or false. So I'm going to cut this box in half, and I'm going to start off strong. So in my first equation, I have 3x. Remember, when there's nothing there, it's multiplying. So 3 times my x value is 0. Minus 7 times y, which is -4. And that equals not 18, 28. Again, I'm going to do it over here. I have y equals, remember my y value is -4, 9 times 0 minus 4. Now we're going to simplify. So 3 times 0 is 0. -7 times -4 is -28 positive 28, equals 28. That was true. So far, so good. And over here, I have -4 equals 9 times 0 is 0. -4. So that's true as well. Step 2 is, how do I figure out the answer to delta math? Okay. If the values make both equations true, which they were, these were both true, then the ordered pair is a solution for the system. Both then it is a solution. However, if even one of them is false, then it is not a solution. So we could have still had 28 equals 28, but then we could have had like -4 equals -5, and then the whole thing would be wrong. Remember, in a system, we have a group. Everything in the group needs to work. So in this particular case, 28 does equal 28, -4 does equal -4. We do have a true system. Okay, we do have a true solution. 0, -4 is a solution. Okay, let's flip the page. Now, solving by graphing. This is awesome because we know how to do this. Okay, we've been doing this for a while now. We need to graph both equations on the same thing, on the same graph, okay? Remember, the easiest way to graph equations is based on which form it's in. We can either, when it's in slope-intercept form, we can plot the y-intercept and count the slope. Or if it is in standard form like this one, we can we can find the x and y intercepts. So I'll show you both ways. And then I'll tell you another way after that too. Okay, so let's plot them. I'm gonna start in red here. Okay, for my standard form equation, which is up here at the top, I have x minus 2y equals 6. X minus 2y equals 6. And when I'm finding the intercepts, what I do is I'm going to plug in 0 for one of the letters and solve. What that does is it just erases one of my terms. Okay, so if I'm plugging in 0 for x, x just goes away because it's 0 now. And I'm going to solve for y. So I have -2y equals 6. Divide by -2 on both sides. Y equals -3. So on my y-axis, I'm going to find -3. 1, 2, 3. And then if I plug in 0 for y, then I have x equals 6. And I don't have to solve any further because x is already by itself. 1, 2, 3, 4, 5, 6. Okay, and then I'm going to draw a line. Hopefully your line looks better than mine. Mine's pretty crooked. Okay. Obviously on Delta Math, your lines will be exact, so it'll be easy to find your intersection. Okay. I'm going to switch colors. And let's plot using slope-intercept form. So I'm going to use the y-intercept. Y-intercept is the 3. I'm going to go 1, 2, 3, find the dot, and my slope is -1/2. That means down 1, right 2. 1, 2. Down 1, right 2. Down 1, right 2. And then I'm going to draw a line. Delta Math will draw the line for you. Okay. Step 2, last step. Find the intersection of the graphs and identify the coordinate. This is your solution. So where the graphs cross, that is your answer. That's what you'll put into Delta Math. That is the true solution, the same way that 0, -4 was our true solution. We're just looking at it a different way, okay? So my solution that I would put into Delta Math is 6, 0. Okay, because that's 1, 2, 3, 4, 5, 6, right, and 0 up or down. Okay, last thing. We're going to hit this a lot harder next in 6.4, but for the moment, I just want to show this to you, okay? We can have the same number of solutions for a system of equations as we do for just one equation. So remember, our number of solutions is 1 0, and infinite. And I want us to draw all these pictures. We're just going to kind of look at it right now. So I'm going to draw 3 coordinate planes really quick. And then we're going to draw 1 standard line for each of them. And then I'm going to talk about the different number of solutions each time. Okay, if we have 1 solution in a system, that means, I'm going to change the color again. That means that my lines hit each other 1 time. So these are actually all going to line up, okay? So it could be anywhere, right? It could be right here, it could be right here, but at the end of the day, when we have 1 solution, it only hits it 1 time, okay? When we have 0 solutions, you can imagine that means it intersects with our line 0 times. And the only time that will ever happen is if we have parallel lines, which is kind of cool. And then last, if we have infinite solutions, that means we have infinite amount of intersections. And that sounds really weird to say, but once I write it down, you're going to be like, oh, duh. If we have infinite intersections, that means they cross at every single point. And that means that they are the exact same line. From the slope to the y-intercept to the x-intercept, everything is the same. They are the exact same. They line up right on top of each other. Okay, so like I said, we'll hit that harder in 6.4, but that is just the last for today. Okay, thank you. Email me if you have any questions.